So trig functions, sine and cosine specifically, are all over all kinds of math and science and real-world applications. And the really neat thing about them is that you can, any graph that you see that's like this, that's got this wave property, can be written as a lot of different equations. So you can write some as cosine functions, and you can write some as sine functions, and the only difference is kind of the shifting, or maybe you have to multiply it by an amplitude to get it to be a certain height. But you can then shift them around, and any cosine graph you have could be written with a sine function, and any sine graph you have could be written with a cosine function. That's how closely related they are. So this particular graph, we could write it in at least 4 different ways. We could write it in an infinite number of ways if we just keep changing the number that we're shifting it, because it cycles, right? And so you could just kind of shift it to the next cycle, and oh, that's a different equation, and shift it to the next cycle. That's just not very interesting, but it is kind of interesting to look at these 4 particular cycles right here. So if we want to represent this as a cosine that has no horizontal shift in it, you can see this is kind of already starting as a cosine graph. Cosine normally starts at 1, and then it starts by going down. But you can see this one is starting at a negative number, and it's starting by going up. And so this graph has obviously been flipped vertically over the x-axis, so that's why there's a negative right here. And then you can see that it's also been stretched to the number 2. So instead of being fluctuating between 1 and negative 1, it's fluctuating between 2 and negative 2. And so it's got a vertical stretch of 2, which is also called the amplitude. So the amplitude of this graph would be 2. But that's the transformation that's missing there. This exact same graph could be the 2 with a positive 2 cosine if I shift it a certain way. So remember that cosine normally starts up here and starts by going down. Well, I either need to shift this point back to here so that it starts and is going down, or I need to shift this point up to here. And you could do it either way you want. It doesn't make any difference. There are 2 possible there. Well, there are an infinite number of possible answers you could put here. There are 2 that are very direct. You could either put x plus pi, that would just be pi, because this is at pi. And so if I want to shift this graph left pi, I could just put x plus pi, which would make it go left, which would make this point come back here. Or you could have put in there minus pi. And if you put in a minus pi, then you're shifting it to the right pi, and you're shifting this point that's at negative pi, you're shifting it up here to 0, and so it would start here, and then it would be the cosine graph from there. Perhaps more interesting, we can totally switch the function. So yes, this could be a cosine graph, but it also could be a sine graph. Now remember that sine normally starts at 0, 0, and starts by going up, and then it comes down like that. So if this one is starting, it needs to start right there. Notice that this shift has gone left by 3 pi over 2. So here is 3 pi over 2. And if we were to shift, if we were to take this graph and shift it left 3 pi over 2, that would be this point here. So if you undo that, then this point at negative 3 pi over 2 would shift up to this point, and then you can see that it would start here and it would go up and then down, and it would follow the normal sine graph. However, there is still that amplitude of 2 that we have to deal with, so there should be a 2 out front right there. But you can see that that's the shift, would just be the 3 pi over 2. If you shift it by 3 pi over 2, you will bring this point that's right here up to right here. So let's look at the last one. It's also a sine graph. This time it's been reflected. So what if we had the normal sine graph that looks like this, right? But if we reflect it, then it's actually going to start by going down and then by going up. And so if we do that one, we actually see that right here. If I could move this point back to right here, then I would, sorry, I need this point. If I could move this point up to right here, then I would start right here, and then I would be going down and then up, and so it would, when you reflected it, it would right itself, and it would then become that sine graph there. And so I just need to put pi over 2 right here, because it would move this is saying that I need that point that's on the left by pi over 2. I need it to shift over here, and then we would have the negative part of the sine because it would be starting by going down instead of going up.